This presentation is brought to you by the SDG Decision Education Center.
And now I'd like to introduce today's first speaker, Dr. Sang-Won Kim. Sang-Won has more than 20 years of experience helping clients make large capital investment decisions, particularly in the energy value chain. His recent work has included engagements to help energy clients develop energy transition strategies. Sang-Won is a partner with Strategic Decisions Group and head of the Global Energy Practice. Sang-Won, you have the floor.
Thank you, Cheyenne. Let me extend my welcome to today's webinar. You may know that SDG has been celebrating 40th year anniversary this year, and we have been putting out a series of webinars to showcase our thought leadership in the area of decision quality and decision science. Today's the last webinar of year 2021. We look forward to bringing you more webinars next year, so please let us know what topics you would like us to address, and you can submit your suggestions through the questions pane. I would like to introduce my colleague and co-presenter today, Tim Sulzer. Tim is an experienced senior oil and gas executive and a change agent with a track record of managing complex organizations and leading multidisciplinary teams. He has more than 20 years of experience in strategy development, asset and technology valuation, and capital allocation. He's a senior engagement manager with SDG. Tim, welcome to today's webinar.
Thanks, Sang-Won. I'm excited to be here and would like to thank our audience for taking a little time out of their day to hear our perspective.
All right, excellent. If we can move on to the next slide. So we would like to begin our webinar today with a quick poll to get to know you better. What is the primary role of your organization in the ongoing energy transition? 1, we produce energy for our customers and use carbon reduction technologies. We develop new technologies that contribute to reducing emissions. We invest in companies that develop new carbon reduction and clean energy technologies. Or we consume a large amount of energy and look for ways to reduce our emissions. And finally, we develop policies to incentivize reduction of carbon emissions. Please make your selection and click submit. I understand that some of you may work for organizations that may play multiple roles. So please select the most perhaps dominant form of the business of the organization. And if none of these apply to you, you can select the one that you are most familiar with or perhaps most interested in. Okay, I can see the polls results are coming in. If you have not made your selection, please do so and click submit. All right, Cheyenne, let's close the poll and show the results. Okay, it looks like most of you are what we would call energy producers, produce energy and use the technologies, and also consume a substantial amount of energy and want to reduce emissions, which we'll call consumers. And it's good to see that we have representations from all of the constituents of the energy transition. Okay, let's move on. The first, introducing 5 entities that shape energy transition. And then we will discuss how each one of those entities can incorporate the concept of decision quality in making their own energy transition decisions. For those of you who have attended our webinar last year, you may remember this slide. We made a point that energy transitions are not new. In the early 1900s, we have moved on from burning wood and what you would call biofuels to burning coal, which triggered industrial revolution. Subsequently, emergence of crude oil and refined oil products and the emergence of natural gas reduced our dependence on coal. And along the way, each one of them lowering the carbon intensity of the fuel that it was replacing. So it is not new that we have come up with a way to use new source of energy that lowered carbon intensity of the ones that we were replacing with. But it seems like the current ongoing energy transition, for the sole purpose of reducing carbon emissions, seems to be unique in a few different ways. The first is the scale. According to one study, to achieve net zero emission by 2050, it would require more than $100 trillion of investment. Considering that US entire world GDP last year was about $85 trillion, it's almost hard to fathom the amount of investment required to achieve this goal. Another striking fact is this casual reference to a future that is so far out. Many organizations and countries are committing to targets out in 30 or in some cases 40 years from now. Considering for a moment what the world was like in 1990s early, or not even mention 1980s, there is a tremendous amount of uncertainty over the next 30 or 40 years. And it puts a lot of challenges and burden for these organizations to commit to a target that's so far out into the future and find ways to achieve those targets through the actions in between. In the meantime, global supply chain disruptions have raised commodity prices of just about everything, and energy has not been an exception. We've seen gas prices soaring in Europe and Asia, in Asia Pacific, and $100 oil price scenario has reemerged. This makes us wonder if the road to energy transition will be a turbulent one with dramatic swings in energy markets, which we all know are cyclical ones to begin with. Let's dig a little deeper into the anatomy of energy transition. At a very basic level, you can think of energy market as a transaction between two different parties. As consumers, perhaps as individuals wanting to charge our phone, to heat our home, we need energy. For large corporations and industrial firms to produce their goods, they need energy as well. There's a set of providers who invest in developing natural resource and delivering into a form that it can be consumed by end users in exchange for compensation. Given the need for energy is such a fundamental activity, there's a role for government to play. They may subsidize the rate that consumers pay or set the rates so that to make sure they're affordable. And they may also pose restrictions or regulate certain aspects of industry operation of energy producers in the area of its impact on the environment. In the system of energy transition, they introduce and enforce policies to encourage reduction of carbon emissions and also investment in renewables. And then there's a technology provider. Reducing carbon emissions requires new technologies. And it's their job to find the most cost-efficient form of those technologies through investment. And they serve energy producers who would use those technologies, and it's also in some cases to consumers as well. They develop batteries, electric vehicles, and develop new technologies to separate carbon and store them. And finally, there's a financier. They don't produce energy. They do not invent any new technologies, and certainly they have no business in making new policies. However, if they see an opportunity to invest and make money, it's their job to find those opportunities to do so. In fact, given the enormous scale of investment that's required to achieve net zero goal, they have emerged as a major player in the energy transition. Let's take a little deeper look at the motivation of these players. For policymakers, their goal is to improve the standard of living for their constituents. They set carbon reduction goals, they set a price on carbon, mandate a certain amount of power to be generated from renewable sources, and they introduce a form of incentives or penalties to reduce carbon. Energy producers' goal is to deliver value to their owners, whether they are public or private entities, and fulfill their social obligations to meet energy needs of their customers. They decide on what form of technologies to use in reducing emissions, and also they have to decide on how to balance the investment between their traditional fossil fuel-based business versus emerging renewables business. Technology providers have to make a return to their investors. They decide on what form of technologies to develop, what markets to target, and in some cases have to decide on whether they should go it alone or partner in developing their technologies. Financiers want to generate return on their investment, oftentimes quickly. They risk their investment on emerging and uncertain technologies and different energy companies. And they decide on what part of value chain to invest in as well. Consumers, finally, want two things. They want to be able to consume energy at an affordable rate, and also they would like to maintain, at least, or perhaps improve their living conditions, including air quality and climate conditions. They decide on what form of energy to use, increasingly participating in self-generation, such as installing solar panels, and they are participating also in voluntarily paying for carbon offset programs, such as TerraPass. See, all of these players in energy transition ecosystem, you may call it, make their own decisions, have their own objectives. And oftentimes they make decisions facing significant uncertainty posed by other entities. In the example of energy producers pursuing a carbon capture and sequestration project, they would make their investment banking on getting a regulatory approval from a policymaker, getting a series of tax incentives from the policymakers, and also banking on technology providers continuing to reduce the cost of technology so that their investment is economic. If we accept the frame that these five entities drive energy transition, and another way to think about it is the decisions they make or actions they take will shape the outcome of energy transition. And I think we can think of the outcome in two different ways. One, the cost of energy, and the other is amount of emissions. What's also important is that it's not just where we get to in 30 or 40 years from now. It's actually how we get there as well. Even if you get to the same endpoint in 30 or 40 years, if the road to get to that endpoint is a turbulent one with dramatic swings in prices and multiple restarts, it will not be in the best interest of these players in the ecosystem and eventually the consumers who would have to bear the consequence of that energy transition. Well, we talk about the fact that many of these players face some unique decisions with respect to energy transition. There's a good news. There is a way to ensure quality in your decisions when the decision is made. That's been SDG's profession and mission over the last 40 years. Through our practice and research, we find that there are 6 elements that you need to ensure in good decision making. Making sure that you are clear about the decisions you make, that's the frame. Make sure you consider a wide range of uncertainty, a wide range of options and choices, that's alternatives. Make sure you reflect the range of uncertainty in your decision making, that's information. Make sure that you know what you want, that's the values. Make sure that you put together those elements in a logically correct way, that's the reasoning. And finally, securing the commitment from the decision makers. So in the next section, Tim is going to talk about how each one of these entities can incorporate these elements of decision quality in their energy transition decisions. As we do so, we would like to launch our second poll, a quick one. Are energy transition decisions more complex than other decisions your organization faces? Yes, same, or no? Tim, while we wait for the results to come in, what are some of the complexities that you think you can think of for these players?
Yeah, Sangwon, I've been eagerly waiting the results of this poll because I can certainly think of a lot of reasons why these are more complex. It's hard for me to think of any one reason why they're maybe less complex, other than perhaps organizations don't think they have a choice and are kind of forced into something. But when you think of the complexities, you have a carbon capture, use, and storage, which is creating a market, right, for what is otherwise a waste product. I think it's climate change is certainly politically and emotionally charged. Emotions. Last time I made an emotionally charged decision, it didn't really work out well.
Right.
But also, I don't want to confuse emotions with care, right, and concern. And I think it's all the more important to be objective when looking at these. And then also you have investors who will pay for a lot of this, right? And one thing I've learned about investors is they can be quite fickle when they don't get their returns, and they'll need that in order to continue to invest. So.
Good. I think we have most of the votes. So Cheyenne, please go ahead and close the poll. And I think our viewers do agree with your thought that energy transition's decision at least as complicated as others, and perhaps more so. All right. So Tim, do you want to share how these entities can incorporate decision quality in their decision making?
Yeah, for sure. Thanks, Sangwon. And again, we'll just put it in a little bit of context and in the decision quality frame for a number of these entities that Sangwon described. And I think it's important to start with U.S. state policymakers and see how they are scoping the problem, right? And what specific decisions have they been focusing on? And in doing so, we tried to stay close to home and look at states where SDG have offices: California, Colorado, and Texas. And one thing that their given decision is they've all made commitments to reduce greenhouse gas emissions. And in so doing, they've initially focused on some specific strategic decisions around vehicles, the type of power generation, oil and gas regulation, as well as building codes kind of targeting efficiencies. Further to that, they have a number of decisions that, once these policies are in place, they can make at a later time, right? Such as individual project approval as they relate to these policies, detailed implementation plans, as well as just coordination with some of the counties and municipalities that will be affected by the policies. What was interesting is we kind of dug into the values of each of these states. They're very similar. The economy, which is about job creation, improved living standards, as well as things like affordable housing, as well as health, safety, and the environment. And so then we kind of dug in, and each of the states had an opportunity to consider different choices within those strategic decision areas. Under passenger vehicles, they're incentive-based in terms of electric and zero-emission vehicles, to beginning with those incentives and then phasing out internal combustion engine sales over time. The renewable energy standards are, as far as 100% renewable by 2045, or setting moderate goals and offering consumers, the choice to pay a premium for power. On the oil and gas regulation side, this is where it's very, very different. From a phasing out development completely to kind of that continuum of increasing regulations on emission reporting and drilling restrictions. And finally, looking at things from a efficiency perspective, the choices range from, having kind of electric ready everything in new buildings to using the international energy conservation codes that are already in existence. And looking at these 3 states, California's is a kind of strategic theme of aggressive zero emission. You can kind of see the choices that, that they made under those strategic decisions. Colorado's theme is an incentives or restriction based, and kind of targeting some increased level of efficiency standards. And then finally, Texas has a bit of a market based. What's interesting is you look at all of these and they each have very similar values as it relates to economy, health, wellness, environment, but they must have very different understandings of uncertainty, right? So I think it's really quite fascinating, the range of choices here, and ultimately how states are thinking about the broader strategic alternatives differently. At a global level, many nations, including the U.S., have pledged, net zero emissions in the next quarter to half a century. The International Energy Agency put out a net zero emissions scenario. And on this graph here, we show on the x-axis, this is gigatons of CO2 emitted currently in the globe, roughly 34 gigatons per year. The tan bars show the increased activity on a global level. And then the colored bars show mitigation measures, ranging from behavioral changes, in other words, using less energy, to different energy mixes from a renewable perspective. And then at the bottom there's CCUS, which is carbon capture, use, and storage. We'll take a look at how this creates an even more complicated web as an ecosystem that Sang-Won described in the these different entities. And certainly, technology providers are working on hydrogen-based types of technology, and then energy producers very much looking at the carbon capture, use, and storage. I do want to highlight on here that red bar there out in 2050 represents about 5 gigatons per year of CO2 required in this specific scenario. There's obviously other scenarios where maybe that 5 gigatons could be as much as 15 or 18 gigatons a year. But in this particular case, the 230 BCF a day of gas is actually twice the current production of natural gas in the US, which is about 111 BCF a day. So certainly a big opportunity, right? And I think a natural player in that are oil and gas producers. And oil and gas production and exploration has been honing its technical understanding over the last century or more. And containment from that perspective is the ability of a reservoir to hold hydrocarbons that migrated there over geologic time, millions of years. Reservoir capacity from an exploration production perspective is around porosity, area, and thickness. And then producibility is the ability for that oil and gas reservoir to produce at a commercial rate. Our colleague Brian Ruskin put together a great LinkedIn article around carbon sequestration and the risks and uncertainties associated with it. And what's interesting is those elements are kind of very much the same as traditional exploration and production. The real key difference is that ability to inject into the reservoir at a commercial rate. And needless to say, I think it's, what's really important is each of these elements must be assessed using the appropriate range of uncertainty. I won't go through this complex web in detail, but suffice it to say it's very complicated. And not every reservoir used for sequestration is going to perform the same. And in fact, a lot of those uncertainties are going to be learned over time. And very complicated, and not at all unlike what exploration and production has been in the oil and gas industry. As I'd mentioned, the hydrogen-based energy is another major or significant mitigation measure highlighted in the IEA's net zero scenario. And for a good reason. Hydrogen is the most abundant element in the universe, but it doesn't exist on its own. It needs to be chemically separated from a chemical compound. I find that most people aren't really interested in the chemistry behind it, so I won't bore you with that. But I do want to say that in each of these, oftentimes a tremendous amount of energy is required for these reactions to occur. And in fact, and sometimes it takes more energy than the freed hydrogen actually provides. But that said, these benefits, the energy density, unlike a solar panel, hydrogen has the energy density to propel an aircraft. It's incredibly abundant and it burns clean, along with the challenges around, it requires extraction, it's difficult to store and transport, and highly flammable, have led industry from investors, entrepreneurs, and big industrials to come up with some very diverse hydrogen strategies. As we looked at this, kind of focused on about 5 strategic decisions that companies are looking at. A target market, who ultimately uses that hydrogen? Is it the electricity grid, or as I'd mentioned, with its energy density focused around transportation? The application is an interesting one in terms of using an internal combustion engine, which is a very known technology, versus an emerging fuel cell technology. We talked about hydrogen production and the need for a chemical process to free hydrogen. Transportation and storage is a very interesting one as we look at the energy transition that Sang-Wan showed, right? You can pile up coal, you can stick oil in a jug. We've spent over 40 years developing complex infrastructure around natural gas, and then hydrogen is just another magnitude more difficult because it is very light, very flammable, and creates some challenges from a transportation and storage perspective. And then partnering is an interesting one that we'll kind of highlight as we look at some of the strategic themes that industry are pursuing. The Target the Seas is one that's very focused on marine vessels and using kind of that known engine technology, relying on third party to provide the hydrogen, and then partnering with those customers who are obviously looking to reduce their carbon footprint. Partnering is an interesting because it's really around cross industry where you find folks that provide complementary skills. One example is Chevron and Toyota have announced a partnership. In the case of obviously Chevron has the chemical processing know-how as well as the logistics around storage and transportation, and then certainly Toyota has led the way in engine development, car manufacturing, and so a really interesting way to tackle what is a long-term bet, right? This is a 10+ year emerging market and technologies. Diversified might be something a little bit that a large industrial, say like a Mitsubishi, would pursue, where they would pursue a lot of the different options under these strategic alternatives. And then finally, this microgrid technology. There's a company out called Bloom Energy, and I think perhaps looking to be a solution to what otherwise is some unreliable at times renewable energies, and to provide that hydrogen energy when the wind doesn't blow and the sun doesn't shine. So these diverse set of alternatives are certainly going to require a lot of capital. And investors and financiers, as we've described them, will play an incredibly important role, and they certainly see the market size. So carbon capture, use, and storage will be a huge piece of the mitigation standards if we want to get to a net zero scenario. And investors certainly want their returns, and they pick the instrument that they use, each of which has an increasing perception of risk. Right? You take the one extreme, debt will have a pledged asset that has a relatively known valuation, where on the other extreme, private equity, though they say they will not take technology risks, but they certainly are willing to take risks, but their target returns are certainly in the 15% and sometimes often over 30%. In terms of their values and trade-offs, again, it's about returns, the ability to manage uncertainties. What's the exit option, right? Private equity certainly isn't going to invest in something that doesn't have a clear exit, and then that level of control. With these values, then they'll also have trade-offs when looking at similar value propositions. Perhaps look at the investment diversity in their existing portfolio, technology maturation, which actually leads then to the next, just concept around how can investors think about and look at the way technology changes over time. As an oil and gas guy, it's easy to pick on a way we've looked at it from an exploration perspective, but there's this concept of a kind of technological creaming curve defined by cumulative wells drilled, right? Another way to look at it is capital spent and activity in a space versus on the y-axis, a cumulative discovered volume. And if you take this example here and just kind of highlight maybe how a Gulf of Mexico has evolved over time, 3D seismic provided that kind of jump, right, from an otherwise kind of asymptotic technical advancement to a significant jump in new discoveries of volumes, as well as then deep water drilling. And so as we think about this, how might you consider it as it relates to carbon sequestration? Perhaps the x-axis is injected volume, and the y-axis is capacity discovered. And then kind of think through what might be the 3D seismic and the deep water drilling as it relates to carbon sequestration. Maybe it's 4D seismic, where you can really see where how well the reservoir is containing that CO2 as it's injected. And then the other interesting one is this whole concept of a carbon market, right? This exchange for carbon credits. Perhaps on the x-axis, we may look at number of trades in the space, and really trying to seek that stability in a market, right? And this is maybe where policies come into play to become those sort of events that get you off of a kind of a stale or stagnant innovation. And certainly we've kind of seen, as we look at what came out of the COP26, is at least some agreement around what maybe a carbon market would look like. So certainly a lot of exciting things and a lot of market development and ways to invest in energy transition and provide returns for investors. I think now we're going to kind of finalize our last poll here, and I'll turn it over to Sang-Wan.
All right. So our last poll. Imagine yourself as a portfolio manager of an investment fund. You don't need this money to pay bills or retire, but you would like to generate a decent return and more return than less. Consider investment opportunities in the energy transition world, and think about these choices in improving energy efficiency, such as improving the gas mileage, vast array of CCS technologies and projects, or those renewable technologies that already exist, and wind and solar that has come down on the cost curve quite a bit, and perhaps emerging technologies, hydrogen, battery storage, direct air capture. They're kind of still new and emerging technologies. Or perhaps we take the climate change as given, and perhaps efforts to make investment to build a resilient infrastructure, or build a habitat for those who would be affected by raise of sea level, for example. So we'll give you multiple choice. Think of yourself as someone who's allocating capital across these opportunities. What would be your top two investment choices? So please select your top two and click submit. Tim, you showed some really interesting examples of how different entities can adopt decision quality thinking, the range of choices. What would your portfolio look like?
Yeah, Sang-Won, and I think I have the ability to see the poll coming in here, and I find it very, very interesting in terms of how it's coming in, and I don't really seek to be contrarian, but I do think sometimes it's fun to have be the contrarian. But from my perspective, I think improving efficiencies, energy efficiencies, are really going to be important. And frankly, provide a lot of opportunities to see returns. And then my second choice is, I think, efforts to adapt to climate change. I think those are kind of my top two choices. And as we see the poll come in, I don't know, maybe time to close it. It looks like we have about 81% in. But
yeah,
as I think about improving energy efficiency, I'll make a bold statement. But if I were to bet, I would say our energy consumption as a globe is not going to go down, right? Especially when you think of these new technologies we have, like Bitcoin, which uses between 8 and 15 gigawatt hours of energy just to mine the coins, and that's I think the city of New York uses 6 gigawatt hours, right? So I mean, we have all these technologies, and then this meta world, or whatever the next kind of Facebook gadget requires energy, right, to cool those server farms. And but I do think it's going to have to be energy efficiency, and not just efficiency, but how do we not waste energy, right? It's kind of that whole combined cycle concept, in terms of energy production. So yeah, I'd go with the first and the last there.
All right, good to get your advice there. So it looks like actually majority, I guess, out of the top two choice was the new and emerging technologies, and then followed by kind of more existing technology. But then other choices also have received quite a few votes. So perhaps if you have an opportunity to invest in energy transition technologies, perhaps you can use this as a kind of barometer of how you want to make your bets. All right, let's move on to wrap it up. So we've talked about how these different players in energy transition can adopt the thinking of decision quality in approaching the unique decisions that they face. In the case of US state policymakers, we talked about the range of decisions that they face and what are really strategic and what are later decisions, and then the range of policy choices they have in driving their states basically move to get towards net zero. We talked about the challenges and benefits of hydrogen technology and the wide range of alternatives the hydrogen technology developer would need to consider. And then we looked at this enormous opportunity associated with the carbon capture and storage and the complexity of the decisions that are present in selecting a site for capturing and storing carbons. And then we finally looked at the range of kind of investment vehicles available for investor in the investing technologies, the values that they look for, and this interesting concept of breakthrough technology, where there's basically a nonlinear point in terms of activity and in terms of cost coming down enough so that it could be more widely available for players to adopt. So it's we see the efforts out there for some of these players come together and collaborate on their decision making. COP26 that just wrapped up over the weekend is a great example, primarily driven by policymakers. There's an organization like OGCI, which are really driven primarily by energy group of large energy producers. And there's an organization out there like Breakthrough Energy, founded by Bill Gates, who considers achieving net zero as actually a bigger challenge than putting a personal computer in everyone's pocket. It's primarily working as a financier and investing in technologies, but also do some technology development and also partner with policymakers as well. While there's an effort among these players in the ecosystem to collaborate on their decision making, let's accept the fact that it probably is not feasible to have all of these players come together on the same table to make a collective choice. What we can hope for is each one of these players to make their decisions well by considering a wide range of alternatives, reflecting the range of uncertainty, and facing or thinking about the values clearly in terms of what they want. Because when each of these players make the best decision they could, the outcome of it is something that as a society, we will have to accept. It may not necessarily be the outcome of reaching a net zero, or may not even be the best chance of reaching a net zero outcome 30 or 40 years from now. But if each one of those entities made the best decision they could, I think by definition, that will give us a balance between energy cost and amount of emissions as two main outcomes of energy transition. All right, I think that wraps up the webinar today. We have plenty of resources available on our website. Please come and check out our past webinars and papers. I would like to, I think we have a few minutes to address questions. So let me see. One question on how effective is carbon capture and storage for a sustainable energy future? Tim, do you want to address that one?
Yeah, I mean, I think it's, one, it's certainly a critical part of what we, what we're charged with in terms of trying to get to net zero. I think the sustainability will be interesting because it is hard, right? I mean, finding an oil and gas reservoir that's commercial was really difficult over the last time. I mean, you obviously do have success, but it also comes with a lot of, dry holes. And so I think that's, it'll be interesting to see how that, changes. The other thing is I know there's, some potential to maybe where you inject CO2 into the ground and it actually solidifies, as it reacts with the minerals in the rock, say a basalt, I think is one potential example. So I think there's in order for it to be sustainable, I think the technology and how it works is really going to have to evolve. It's certainly a huge market. So, if we can sort out the how it's priced.
Right, and it's like there's a room for additional emerging technologies as well. I think we could probably have room for one more question. Let me take on this one. How can you normalize decisions despite very different ROIs between green projects and hydrocarbon ones? This is something we hear quite often, and I think it implies that ROIs for green projects are lower than the hydrocarbon ones. I guess few things that I can think of are perhaps the days of basically summarizing everything in a single financial metric in making decision may be numbered. Now more than ever, public and the society are expecting organizations to weigh reflect carbon emissions or other metrics in their decision making as well. So I guess our response would be, if we reflect impact like reduction in carbon intensity emissions in conjunction with financial measures such as ROI, the answer may be different. Another fact that I want to mention is that, as Tim pointed out, there's tremendous uncertainty in terms of how some of these technologies will develop over time. We've seen the emergence of 3D seismic, hydraulic fracturing technology, floating LNG technologies. These technologies can have basically nonlinear impact on the evolution of the market. So when we evaluate green projects, making sure there is a way to reflect those breakthrough points in terms of the likelihood and also the timing of those breakthrough technologies, that may actually change the range of ROI that we recognize from those green projects. Well, we're up on time. Hopefully the content was interesting. We try to pack a lot of stuff in a short period of time. Any questions that we were not able to address, we'll try to address them afterwards. So thank you, Tim, and thank you for joining us. And I would like to turn it over to Cheyenne to wrap up.
Thank you, Sang-Won and Tim, and thank you everyone for attending today's webinar.